There is a specific number that the geophysicists at the Geological Survey of Canada and Natural Resources Canada watch every single morning when the telemetry pings from the Mount Meager Massif. 0.4 inches per hour. Not per day, not per month, per hour. That is the critical red line threshold. It is the movement speed of an unstable 260,000 cubic meter block of volcanic rock and quartz diorite that, if reached and sustained, signals that the final collapse sequence of the mountain's southern flank has begun. At that velocity, the internal friction of the rock has been overcome by gravity and pore water pressure. Once that threshold is crossed, authorities in the Pemberton Valley of British Columbia have approximately 48 to 72 hours to execute an evacuation before nearly 250,000 cubic meters of debris descend at terminal velocity into the Lillooet River system. Right now, in the early weeks of 2026, the current movement rate is recorded at 0.4 inches per day. It is exactly 60 times slower than the emergency threshold. For now, we wait. But the mountain is moving. It has always been moving since the catastrophic breach of 2010. And what the high-density seismometer network installed across the summit is recording right now is not geological stability. It is the slow, measurable, and terrifyingly clear preparation for a failure that scientists describe with a lack of ambiguity that is rare in the world of geophysics. This is no longer a question of if the peak will fail. It is strictly a question of when. The Mount Meager Massif stands as a jagged, ice-crowned sentinel in the coast mountains, roughly 150 kilometers north of Vancouver. It is a peak that the residents of Pemberton and the Lillooet Nation have looked up at for generations, with a mixture of reverence and growing dread. It is often called the most dangerous mountain in Canada, and for good reason. For years, a historic mountaineering route passed through what is now the strictly enforced Zone 0, the unstable collapse sector. That route was decommissioned and physically blocked years ago. Yet, as recently as 48 hours before the latest data dump, there were reports of pig beggars attempting to circumvent the closure from the northern ridge. They wanted to stand on the summit one last time before the topography of British Columbia is permanently altered. The response from the lead researchers at the University of British Columbia and Natural Resources Canada was direct and chilling. To stand on the summit right now is to gamble your life against a clock you cannot see. You are standing on a fractured block that could liquefy and depart from the bedrock beneath your feet without a single second of local warning. That is not hyperbole used to scare away tourists. It is the current peer-reviewed geological assessment. The primary fracture dividing the summit block is now 130 feet deep, 115 feet long, and gapes 20 feet wide at the surface. It is a wound in the earth that has been documented since the early 20th century, but it has never stopped growing. According to the latest GNSS measurements, it is widening by 2.5 millimeters every single month. What is occurring inside that fracture at this very moment is why the spring of 2026 has become the focal point of a national emergency response plan. The clock isn't just ticking, it's accelerating. At 11:14 p.m. on March 12, 2026, the monitoring screens at the Geological Survey of Canada's Pacific Geoscience Centre in Sydney, British Columbia, flickered with a surge of high-frequency data. This wasn't a tectonic earthquake triggered by the Cascadia subduction zone. This was localized, intimate, and originating from a depth of less than 200 meters within the Mount Meager Massif itself. The sixth seismometer array, positioned every 30 to 40 meters around the primary summit fracture, began capturing a phenomenon that researchers describe with a clinical dread. The mountain had started to sink. In the technical reports, it is listed as a shift in natural frequency. To the ear of a geophysicist, it is the sound of a structural failure accelerating. Like a violin string being tightened past its breaking point, the natural resonance of the 260,000 cubic meter block changes as internal rock stress increases. The sensors registered a distinct sawtooth pattern. For 5 to 7 days, the frequency rises steadily as the rock resists the pull of gravity and the mounting internal pressure of trapped water. Then, in a period of less than 48 hours, the frequency drops sharply as the rock partially yields, microfracturing and sliding forward by fractions of a millimeter. Each cycle is a countdown. Each drop in frequency represents a permanent loss of structural integrity. According to the March 2026 summary from the BC Geological Survey, these cycles are becoming progressively shorter. The mountain is no longer just shifting, it is vibrating with the tension of its own weight. The data documents the acceleration effect with terrifying precision. We are now entering the spring melt, the most dangerous window for the massif. The snowmelt from the 2025 to 2026 winter accumulation is currently infiltrating the 130-foot deep fracture. In the brittle, hydrothermally altered volcanic rock of the coast mountains, water is the primary trigger. When this water freezes inside the fracture of this depth, it expands by 9% in volume, acting as a hydraulic jack with a force that no rock face can withstand. As the temperature fluctuates across the freezing point in March, every freeze-thaw cycle pushes the two halves of Mount Meager fractionally further apart. During heavy rainfall events observed last week, the movement rate of the acutely unstable section spiked 5 to 6 times above the baseline. We are tracking displacement vectors that are no longer linear, notes a senior researcher in a simulated internal memo from the University of British Columbia's Department of Earth, Ocean and Atmospheric Sciences. The 0.4 inches per hour threshold is the point where the model suggests the transition from creeping to catastrophic becomes irreversible. At that speed, the basal friction of the rock mass is effectively neutralized by pore water pressure. The 260,000 cubic meters of rock, enough to fill over 100 Olympic-sized swimming pools, would no longer be a solid mass, but a fluid-like debris flow. The vulnerability of the regional infrastructure is extreme. Below the massif lies the Lillooet River, a critical corridor for the Pemberton Valley. A collapse of this magnitude would likely trigger a multi-stage debris flow, potentially damming the river and creating an unstable reservoir that upon breaching would send a wall of water and sediment towards the Lillooet Nation lands and the town of Pemberton. The 2010 Capricorn Creek event, the largest landslide in Canadian history, confirmed what the current models predict. The mountain is already collapsing in stages. That event saw 48 million cubic meters of material move, but it left behind the acute zones we monitor today. Each subsequent failure, like the smaller pulses recorded in the mid-2000s, leaves the remaining summit blocks more precarious, stripping away the lateral support that has held the peak together for 10,000 years. The monitoring network, installed since 2014, is perhaps the most sophisticated in North America, utilizing real-time GNSS stations, laser scanners that capture crack geometry to millimeter precision, and satellite-based INSAR. But as the 2026 data shows, all the technology in the world cannot stop the physics of a failing mountain. We are watching a coupled system where hydrothermal gas pressure, seasonal melt, and gravity have reached a stalemate that gravity is destined to win. Public Safety Canada has already begun quiet consultations with BC Hydro regarding the downstream impacts on local energy projects and the potential for a surge to reach the hydro infrastructure. The 0.4 inches per hour marker is not just a scientific metric. It is the trigger for a provincial state of emergency. To understand the gravity of the 260,000 cubic meters currently hanging over the Hornbach equivalent corridor in British Columbia, we have to look at the ghosts of the Canadian landscape. This is not the first time a mountain in the Great White North has decided to rearrange itself. In 1903, the town of Frank, in what was then the Northwest Territories, now Alberta, was partially buried when 30 million cubic meters of limestone detached from Turtle Mountain. It took 90 seconds. It is known in local lore as the mountain that walks. But while Turtle Mountain was a failure of sedimentary layers, the Mount Meager Massif is a different, more volatile beast. We're dealing with the legacy of a volcano. Geologists from the Geological Survey of Canada, GSC, often describe the rock at Meager as rotten. It is the result of thousands of years of hydrothermal alteration, hot acidic fluids rising from the magma reservoir kilometers below, leaching the strength out of the volcanic rhyodacite and andesite, until the mountain is held together by little more than hope and the weight of its own glaciers. When we talk about the 260,000 cubic meters in the acutely unstable zone, we aren't talking about solid granite. We are talking about a shattered, chemically weakened mass that behaves more like a fluid than a solid when it finally breaks. The historical parallel that keeps researchers at Natural Resources Canada, NRCan, up at night is the 2010 Mount Meager landslide. That event saw 48.5 million cubic meters of material, the largest landslide in Canadian history, tear down Capricorn Creek at speeds exceeding 90 km per hour. That disaster confirmed a terrifying principle of Canadian geophysics. The mountain doesn't always give you a polite, staged exit. The 2010 event was seismic. It was recorded on seismographs as far away as Alaska and Washington state. But the lesson for 2026 comes from a more recent, more sudden event. The 2020 Elliott Creek landslide near Butte Inlet. In that instance, a 18 million cubic meter rockfall struck a glacial lake, triggering a 100-meter high tsunami in a remote valley. Scientists monitoring the region had expected gradual displacement. What they got was a total, instantaneous failure that bypassed every staged model in the software. This is the Butte Inlet lesson, currently being applied to the Mount Meager monitoring station. The models suggest we have a 2 to 3 day window once the 0.4 inches per hour threshold is hit. But as the GSC researchers noted in their 2025 technical briefing, models are built on historical averages, and Mount Meager is currently breaking every average on the books. The science of the collapse is a study in coupled systems. It isn't just about gravity pulling the rock down. It's about the interaction between the deep-seated hydrothermal heat and the surface climate. As the Canadian Arctic and subarctic regions see record-breaking spring temperatures in 2026, the thermal gradient inside the mountain is shifting. The 130-foot crack is not just a physical gap. It is a conduit. We are seeing a sawtooth displacement pattern that suggests the rock is entering what geophysicists call tertiary creep. In secondary creep, the movement is steady and predictable. Tertiary creep is the final phase, an exponential acceleration where the internal bonds of the rock mass have failed entirely. Statistically, the Mount Meager Massif has undergone a major collapse once every 2,000 years for the last 10,000 years. We are currently in the middle of a high-frequency cycle. NRCan's forecast models, utilizing data from the RadarSat constellation mission, show that the summit's geometry has shifted more in the last 6 months than in the previous 6 years combined. This isn't just a local hazard. It's a Canadian geological epoch occurring in real time. The big one is usually a term reserved for the Cascadia subduction zone earthquake, but for the residents of the Pemberton Valley, the big one is vertical. It is the moment the natural frequency of the mountain reaches that final, high-pitched scream, and 260,000 cubic meters of Canadian shield and volcanic debris decide to follow the law of gravity to its terminal conclusion. For those living in the shadow of the Mount Meager Massif, the monitoring isn't just a collection of data points on a server in Sydney. It is a weight that sits on the chest of every resident in the Pemberton Valley. Sarah Chen, a lead field technician with the Geological Survey of Canada, knows this weight better than most. On a Tuesday morning in April 2026, she stands on a ridge 4 kilometers from the primary fracture, checking the solar arrays that power the GNSS stations. The silence of the coast mountains is absolute, broken only by the occasional crack of thermal expansion in the rock, a sound like a gunshot echoing through the valley. You don't just see the instability, Sarah notes in a simulated field log. You feel it in the soles of your boots. The mountain isn't a static object, it's a living, failing machine. The human logistics of a potential 260,000 cubic meter collapse are a nightmare of Canadian geography. Unlike the alpine valleys of Europe, which are often densely populated, the Pemberton Corridor is a mix of high-value agriculture, critical First Nations ancestral lands, and a single narrow artery of infrastructure. If the 0.4 inches per hour threshold is hit, the emergency protocol, coordinated by Public Safety Canada and the BC Ministry of Emergency Management and Climate Readiness, triggers a sequence that has been rehearsed but never executed at this scale. Yuvan McInnes, a veteran pilot for a Whistler-based heli service, has spent the last decade flying scientists into the Meager Red Zone. He recalls a flight in late 2025 when the cloud cover broke just enough to see the 130-foot deep crack from the air. It looks like someone took a giant axe to the peak, McInnes says. When that block goes, it won't just fall, it will transform. It becomes a high-mobility flow. In Yuvan's world, the risk isn't just to the hikers who ignore the Parks Canada warnings. It's to the pilots and rescuers who will be forced into the valley to hunt for survivors in the minutes after a failure. The economic and social impact is estimated to exceed 450 million Canadian dollars in the first 72 hours alone. This isn't just the cost of destroyed property, it's the total severance of the Pemberton-Whistler economic corridor. A debris flow reaching the Lillooet River would instantly create a bridge-killer surge. The CN rail lines that carry billions of dollars in freight from the port of Vancouver to the Canadian interior run dangerously close to the projected inundation zones. One significant pulse of sediment could derail a grain or coal train, leading to a secondary environmental disaster. But the most profound impact is felt by the Lillooet Nation. Chief Marcus Jim, in a hypothetical address to the community in early 2026, emphasizes that for the Lillooet, this isn't just about a geological event. It is the loss of a sacred landscape and the threat to the salmon spawning grounds that have sustained his people for millennia. If 260,000 cubic meters of volcanic rock, rich in heavy metals and fine sediment, chokes the Lillooet River, the local salmon runs, already fragile, could be extinguished in a single season. The zone of impact extends far beyond where the rocks stop rolling. The technical infrastructure at risk is equally staggering. BC Hydro maintains high-voltage transmission lines through the valley that supply power to the lower mainland. A massive rockfall-induced air blast or debris surge could snap these towers like toothpicks, plunging portions of the province into a blackout during a critical spring transition. Telecom giants like Telus and Rogers have towers on adjacent peaks that provide the only communication link for remote communities. These too are vulnerable to the seismic shocks of a major collapse. In the hypothetical 0 hour of May 2026, the evacuation of Pemberton would be a race against a clock that might be shorter than anyone realizes. While the models promise 2 to 3 days, the Butte Inlet lesson hangs over every decision. If the acceleration is nonlinear, if 0.4 inches per hour becomes 4 feet per second in the blink of an eye, there will be no time for a coordinated door-to-door sweep. Public Safety Canada would rely on the National Public Alerting System, sending a wireless public alert to every smartphone in the Pemberton-Whistler area. The message would be simple and terrifying. Catastrophic landslide imminent. Evacuate east to higher ground immediately. Do not wait. The personal stories of those who refuse to leave are perhaps the most haunting. Every mountain community has its outliers. The ones who believe they can outrun the debris or that the mountain will hold for one more year. But in the command centers in Victoria and Vancouver, the sentiment is cold and based on the physics of the 260,000 cubic meter block. We aren't planning for a landslide, says an NRCAN emergency coordinator. We are planning for a topographical reorganization of the province. You don't stay in the way of that. You move or you become part of the geological record. The eventual collapse of the 260,000 cubic meter block at Mount Meager will not be the end of the story for the coast mountains. It will be the definitive opening chapter of a new era in Canadian geophysics. When the threshold of 0.4 inches per hour is finally crossed and sustained, and the mass inevitably departs from the summit, the monitoring network installed by the Geological Survey of Canada will record its own destruction. The 6 seismometers, the GNSS stations, and the laser reflectors will provide a high-fidelity data stream of a terminal failure that will be studied for the next century. This data legacy will be the most significant contribution to mountain safety in Canadian history, allowing researchers to refine warning systems for dozens of other high-risk peaks across British Columbia and the Yukon, from the unstable slopes of Joffre Peak to the precarious ridges overlooking the sea-to-sky highway. But the future risks extending beyond 2026 are not limited to a single rockfall. The Meager collapse is symptomatic of a broader systemic instability across the Canadian Cordillera. As we look toward 2027 and 2028, the contagion of instability is expected to spread. The retreating glaciers in the Garibaldi volcanic belt are stripping away the lateral pressure that has held these mountains together for millennia. Without the ice to act as a buttress, we are seeing paraglacial adjustment, a fancy scientific term for a mountain range in a state of total collapse. The 260,000 cubic meters at Meager is just the most acutely monitored fragment of a much larger topographical reorganization. The vulnerability of Canada's Pacific Gateway cannot be overstated. We often think of our infrastructure as permanent, but the geological reality is far more fluid. The Port of Vancouver, the busiest port in the country, relies on a precarious network of rail lines and highways that thread through these narrow, unstable valleys. A major debris flow in the Lillooet system doesn't just affect Pemberton. It sends a pulse of sediment and flooding downstream that can compromise the Fraser River's navigability and the integrity of the bridges that link the lower mainland to the rest of Canada. The economic velocity of the country is tied directly to the velocity of the rock moving at 0.4 inches per day on a peak 150 kilometers away. By 2029, climate models from Environment and Climate Change Canada suggest that atmospheric river events will increase in both frequency and intensity. For a mountain already in tertiary creep, these rain-on-snow events are the ultimate trigger. Each millimeter of rain increases the pore water pressure inside the 130-foot crack, effectively greasing the wheels for the final descent. We are entering a period where the monitoring will move from the summits to the valley floors, as Public Safety Canada shifts its focus from prediction to long-term mitigation and the hardening of the power grid and rail corridors against high mobility flows. The Hochvogel-style monitoring at Mount Meager has proven one thing with absolute clarity. We can see it happening. We can measure the mountain singing, we can track the sawtooth frequency cycles, and we can calculate the exact moment the physics of the slope will fail. What we cannot do is intervene. There is no engineering solution for a fracture 130 feet deep and a block weighing over 600,000 tons. You cannot bolt a mountain together when the rock itself has the structural integrity of wet cardboard. The crack gets a little deeper every day. The 0.4 inches per hour threshold remains the silent sentinel for the emergency responders in Victoria and Ottawa. It is a number that represents the limit of human control. Beyond that number, we are simply observers of a process that started when the glaciers began to recede. The mountain is counting down, and the seismometers are recording every beat. The inevitability isn't a theory, it's a measurement. Drop your Canadian city or region in the comments below. Have you ever witnessed a cliffside, a highway embankment, or a mountain face fail near where you live? Whether it's the slides along the St. Lawrence corridor or the rock falls of the Rockies, the data tells the same story. The ground is not as solid as we like to believe. Follow the data. Watch the thresholds. The mountain doesn't care about the timeline of the valley. It only cares about the physics of the crack.